Good afternoon, friends. Let's begin our afternoon session. I'm Roger Bagnall, the president of the American Philosophical Society, and it is a very great pleasure to welcome you to La Jolla and to the fall general meeting of our members. We have about 240 people registered for the meeting this week, which is a great turnout for a first foray to the West Coast in almost 20 years. We also have 30 members attending their first APS meeting. They will be formally inducted into the society over the next 3 days. The new members are wearing pink name tags, the only violation of our nullo discrimine principle. Please make sure to welcome them. While this is not the first time that the APS has hosted one of its meetings away from Philadelphia, it's the first in a long while. A very big thank you goes to APS member Sarah Miller-McCune and to Sage Publishing for their generous contribution, without which this would certainly not have been possible. It has made all of it not only possible, but attractive, and we're most grateful for the opportunity to bring APS to La Jolla. We also extend our respect to the Kumeyaay people and acknowledge that we are meeting within their unceded homelands. The American Philosophical Society itself, in normal days, resides in Lenapehoking, the ancestral homelands of the Lenape people. The Society recognizes the ongoing presence and perseverance of both the Kumeyaay and Lenape people and expresses sincere thanks for both the past and ongoing generosity of numerous indigenous communities and individuals who have offered us their guidance, expertise, and opportunities for collaboration. I'm sure that you have all turned off or at least silenced your cell phones and whatnot by now, but should that not be the case by any chance, please take this opportunity to do so. As always, we begin our meeting by standing to remember our members who have died since we last met. I ask you to stand now while I read the names. John Boardman on May 23rd, 2024, at age 96, elected in 1999. John Brauman on August 23rd, 2024, at age, is this right? These must be 2025 dates. At age 86, elected in 2004. Leon Cooper on October 23rd, at age 94, elected in 1973. Robert Denard on April 23rd at age 91, elected in 1997. Wolfram Fischer on April 28th at age 96, elected in 1995. Joseph Gall on September 12th at age 96, elected in 1989. Diane Griffin on October 28th at age 84, elected in 2018. John D. Hawkins on February 1st at age 83, elected in 1998. T.D. Lee on August 4th at age 97, elected in 1972. Barbara Oberg, this can't be the right list. I'm sorry, this is last year's list. This really is not correct. I'm sorry, we will have to do this at the beginning of another session. Please be seated. Now, however, I will do one other thing. As members know, one of our losses this year was Clyde Barker. As veterans know, we do not deliver memorial minutes at our meetings for members whom we have recently lost. These appear as biographical memoirs in the proceedings. But all rules have exceptions. and Clyde Barker was an exception, if ever there was one. We will in due course, naturally, publish a proper account of his distinction as a pioneering surgeon, a leader in medicine and medical education, a superb speaker at our meetings, a book author even in his 90s, and of course, a great tennis champion. But you will forgive me if I take just a moment today to express my gratitude and that of the membership for Clyde's service to the Society. He was not only a wonderful president for slightly over 6 years, but the key figure in keeping the Society on course during the months after Keith Thompson's illness left us without executive leadership. For those of us who have followed him in the presidency, he was an admired model of good judgment and tact, not to mention institutional memory and loyalty. He continued after his presidency to serve the APS on its publications committee, and his presence at our meetings was always a joy, his mind sharp to the end. Even in a society where there are many ties of deep affection among the members, Clyde stands out as a beloved figure. We're now going to move to the induction of new members. And I just want to say that veterans know that it involves a seemingly interminable handshake with the inductee, in the course of which I recite a formula that has been used since time immemorial, which contains the phrase, "The American Philosophical Society held at Philadelphia for promoting useful knowledge." I will use this canonical phrase so as not to injure the validity of induction, but I want you to know that by it I mean usually held at Philadelphia and today held in La Jolla.
Will Dr. Persis Drell please come forward to the President's desk to sign the roll book and then receive a formal welcome from the President. Mr. President, I have the honor to present Persis Drell, James and Anne Marie Spilker Professor of Material Sciences and Engineering and Physics, Provost Emerita, and former Dean of the School of Engineering at Stanford University. She also served as Director of the U.S. Department of Energy's SLAC National Acceleratory Laboratory. Before joining Stanford University, Dr. Drell was a member of the physics faculty at Cornell University for 14 years. Her research has contributed to the development of the first free electron laser, and she was part of the Fermi Gamma Ray Space Telescope mission that studied the most energy-rich events in space.
By the authority and in the name of the American Philosophical Society, held at Philadelphia for promoting useful knowledge, I do admit you a member thereof. Congratulations.
Will Dr. Ronald Evans please come forward to the President's desk to sign the roll book and then receive a formal welcome from the President. Mr. President, I have the honor to present Ronald Evans, Professor and Director of the Gene Expression Laboratory at the Salk Institute for Biological Sciences. He also holds the March of Dimes Chair in Molecular and Developmental Biology at the University of California, San Diego. Dr. Evans is renowned for his pioneering studies on hormones' normal activities and their roles in disease. This has led to his major discovery of nuclear hormone receptors, which help control sugar, salt, calcium, cholesterol, and fat metabolism, and are primary targets in breast, prostate, and pancreatic cancers. His muscle metabolism studies led to the discovery of exercise mimetics, and this is the part I like, which promotes the benefits of her to characterize and develop large format, low noise infrared detector arrays. As principal investigator at the NIRCam, Dr. Rieke is responsible for making sure that the instrument is built and delivered on time and on budget. How's it going? NIRCam will visualize infrared light, allowing it to examine the early phase of star and galaxy formation and study the shapes and colors of distant galaxies.
By the authority and in the name of the American Philosophical Society, held at Philadelphia for promoting useful knowledge, I do admit you a member thereof. Congratulations.
Will Dr. Valerie Smith please come forward to the President's desk to sign the roll book and then receive a formal welcome from the President. Mr. President, I have the honor to present Valerie Smith, President of Swarthmore College. In her role as President, Dr. Smith has strengthened and expanded initiatives focused on diversity, equity, and inclusion. She has supported curricular innovation. She has improved the campus facilities and has ensured that the college fulfills its commitment to achieve carbon neutrality by 2035. Dr. Smith is a scholar of African American literature, and before joining Swarthmore, she served as the Dean of the college, Director of the Center for African American Studies, and Director of the Center for African American Studies at Princeton University. She was also Chair of the Interdepartmental Program in African American Studies, Co-Director of the Cultural Studies in the African Diaspora Project, and Vice Chair for Graduate Studies at UCLA.
By the authority and in the name of the American Philosophical Society, held at Philadelphia for promoting useful knowledge, I do admit you a member thereof. Congratulations.
Will Dr. J. Craig Venter please come forward to the President's desk to sign the roll book and then receive a formal welcome from the President. Mr. President, I have the honor to present Craig Venter, founder, CEO, and chair of the J. Craig Venter Institute. He is a leading figure in biology, known for his contributions in genomics, including sequencing the first draft human genome, the first complete diploid human genome, and the construction of the first synthetic bacterial cell. Dr. Venter pioneered the notion of pre-symptomatic testing coupled with deep genomic sequencing to assess long-term health of individuals. This was the basis for the formation of Human Longevity, a comprehensive medicine clinic. He is currently applying these same concepts on a great area of unmet need, women's health, aiming to build the first of its kind for-profit transformative women's health center.
By the authority and in the name of the American Philosophical Society, held at Philadelphia for promoting useful knowledge, I do admit you a member thereof. Congratulations.
Will Dr. Mark Wrighton please come forward to the President's desk to sign the roll book and then receive a formal welcome from the President. Mr. President, I have the honor to present Mark Wrighton, Professor and Chancellor Emeritus at Washington University in St. Louis. Under Dr. Wrighton, underlying the conversion of solar energy to chemical fuels and electricity.
By the authority and in the name of the American Philosophical Society, held at Philadelphia for promoting useful knowledge, I do admit you a member thereof. It's now my pleasure to turn the lectern over to Vice President Jacqueline Barton, who will preside over our first session of papers. Jackie.
Good afternoon, and welcome to a West Coast meeting of the American Philosophical Society. How wonderful. My name is Jackie Barton. I'm a chemist from Caltech and Vice President of the APS, and I'll be chairing this afternoon's session. And it is my great pleasure to introduce our first speaker. Biological studies. Under Dr. Jacobs' vision, Qualcomm grew from a startup to a Fortune 500 company, pioneering and developing CDMA wireless technology, which provides us all voice and broadband internet access. Qualcomm is now the world's largest semiconductor supplier of wireless products and a leader in fourth-generation technologies. Since leaving Qualcomm, Dr. Jacobs has dedicated himself to philanthropy, particularly within the science and technology sector, serving on the boards of the Digital Promise Initiative and the University of California President's Engineering Council. Dr. Jacobs has contributed enormously to education through fellowships and scholarships for students in engineering and computer science. Among his many honors, he's a member of the National Academy of Engineering, and he was awarded the National Medal of Technology and Innovation for his development of CDMA. Now, actually, our talk this afternoon with Dr. Jacobs will instead be a conversation, and it will be a conversation with our fearless leader, CEO Patrick Spiro. Please join me in welcoming Irwin Jacobs along with Patrick. And his talk today is called A Conversation with Irwin Jacobs on Science, Technology, and the Future. Thank you.
Well, Irwin, thank you for agreeing to join us and have a conversation looking back on your career, but also looking towards the future and to hear some of your thoughts on what the future may hold for us in the world of science, technology, and the society more generally. When we decided to come to La Jolla, the meetings committee met, and the meetings committee oversees all the programs that we have here. They said, we're in La Jolla. Usually we're in Philadelphia. We need somebody to introduce us to La Jolla, to San Diego, and who can talk about the transformation of San Diego since the founding of, since the 1960s to the present. And the name that everybody said is, you really have to talk to Irwin Jacobs about that, because he's been a big part of San Diego's life, of its economy, of its culture. And so I really appreciate you joining us and for this conversation and welcoming us to San Diego and La Jolla.
Well, indeed, thank you very much for coming here. Yeah. And obviously a lot of interest.
No, it's fantastic. I'm going to talk about it tomorrow, but we have over 250 people registered and really showing that the APS is the American Philosophical Society. We are a national, international body. So, Irwin, I want to start by talking a little bit about your career and how you landed here in San Diego, because you were born and raised in southeastern Massachusetts, just a few miles from where I grew up, went to Cornell, and then you got a PhD in electrical engineering and became a tenured professor at MIT. And so as far as I'm concerned, I'm a historian, so I don't know your field, but to be a tenured professor in engineering at MIT is probably the pinnacle or near to it. And so in 1966, with tenure, you decided to leave it all, head across the country, and come to this new startup, the University of California, San Diego. So what were you thinking?
Well, all these decisions happen, and there are a lot of different factors that come into them. You need to have your family in agreement, et cetera. And this was a decision to leave Boston and come to San Diego was a difficult one. In fact, after receiving the invitation to come out for an interview and look into helping start engineering, although it wasn't called engineering at the time, here at a brand new university was very attractive. But went home, discussed it, unfortunately decided not to come because family, friends, everything was on the East Coast, career. And we had visited California in 64, 65 academic year from MIT and had loved it out here, so we knew we would want to retire at some point here. And Carl turned it down. Second day after turning it down, we were kind of unhappy with the decision. Major rainstorm in the Boston area, took the subway to Harvard Square and then had to get on a bus to Arlington where we live, and got soaking wet, of course, on the way. Joan, my wife, met me at the door, and she said, listen to this. We had been looking to buy a home around Boston. And she read the description of a lovely sounding contemporary home. So I said, great, let's go see it tomorrow morning. And she said, only one trouble, it's in La Jolla. It doesn't take much to flip when you have a decision, both possibly sound good. Anyway, that did flip us. We called and said, if it's still open, we're coming. We had an old van that we had driven cross-country twice. We did it one more time with a family of 4 at this point and moved here to La Jolla.
Oh, that's great. I'll share you my story. My first time in La Jolla, which is 60 years after that. It was with the APS, and I went for a run in downtown La Jolla, and I said, wow, this is spectacular. I think maybe this is where my wife and I can retire. So I got back to the hotel room. I got on Zillow and realized maybe we'll spend a week there when we retire. Because it's changed a lot in those 60 years. Now, so you arrive at a relatively new university, and Dick Atkinson is with us. But you're only there for a brief amount of time, because you then found a company called Linkabit. And a lot of people know about Qualcomm, but your first company was really Linkabit. And can you tell us a little bit about what that company is and what inspired you to leave academy and go into private business?
Yeah, another one of these happy accidents. While at MIT, I had co-authored a textbook on digital communications, the very first such textbook. And so when I moved out here, there were all these requests for consulting. And usually you'll consult a day a week at most. And so I was up at NASA Ames and flying back down to LA, actually, with a couple of friends from UCLA. And I mentioned I had all these requests for consulting. And they said, oh, why don't we start a company and share the consulting? And so that's how Linkabit started. I said, that would be fine as long as I don't have to manage it. Any case, it started and slowly grew. And we began to add some people, including some students that had come out with me to from MIT to finish their PhD. And I finally decided I better take a year's leave and get it organized. So I did that in 71, 72 academic year. And then at the end of that year, had to decide whether to go back to the teaching or to stay with the company. And it was a hard debate, but I had been teaching students for 13 years that this theory that we're teaching would in fact be useful in the real world. And so I decided, well, here's a chance to demonstrate that in fact that theory would be useful. And so that was the way I made that decision.
And here we are at the American Philosophical Society for promoting useful knowledge. And Linkabit is successful, and as I understand, you sell it in the late 70s, early 80s.
80,
And you could retire, but you decide to found another company called Qualcomm. Qualcomm now is one of the largest, if not largest, private employer in San Diego. It has a market capitalization of almost $200 billion. When you founded it, what was your wildest dream for what would happen with it?
Well, making the decision not to go back to teaching and start another company was kind of due to a few other employees from Linkabit that said, let's try to do it again. And Linkabit had grown 50, 60% a year. So I did decide to go ahead and with this other group, start a new company. But I told my wife, Joan, that, at best we'll reach 100 employees. Well, it's over 50,000 now, so that wasn't a good estimate. But it was interesting. Actually, both companies, we started them without a business plan, without a product in mind, and just thinking that digital and wireless would probably be an interesting future. And of course, it turned out that way.
So you began as a scientist, as a professor, but you became an executive and a leader of a company that grew dramatically, tens of thousands of employees. Was there anything that you took from your academic training that was useful as an executive?
A lot. People always ask, what's the difference between your academic life and your business life? And I say, well, part of it's very similar. At the university, particularly with graduate students working on a research project comes, talks with you, you discuss it, give them perhaps a little direction, and off they go. At a business, an employee, you give them an idea for a project or a group. They go off work, come back, you consult some more, and off they go. So in a sense, there's that interesting interaction between yourself and others about technical subjects. But that's only about half the time, because you have this other half where you have to worry about business and finances, meeting payroll, going out, finding customers, etc. Well, at the university, you also spend a lot of time in committees. And so I often point out that the advantage of business over the university in that sphere is you can make a decision.
So if you have any lessons for academics today, maybe they're a professor thinking about how their work could be useful to the world with business and the like, what advice would you give them?
Well, be willing to take some chances, but be also willing to make changes. So someone might have an idea for by the way, you can still hear my Boston accent, might have an idea for a product that they want to work on, and that would be somewhat innovative, and so they'll go in that direction. And I always point out that it's never going to go kids, you're too late, etc. A lot of arrows in the back, but just proceed ahead. The best way to deal with that is to show that your idea is good. I often say that while you're going through different decision points, that you always wake up at 4 a.m. The different issues. If you can fall back asleep, keep going.
That's great. So you mentioned being from southeastern New England, the Boston area, and your first company was actually founded there, if I remember correctly, when you were a young boy during World War II. Do you want to share that story with us?
It wasn't quite a company, but we were renting a two-story home that had just converted from coal to oil for heating. And so there was a coal bin, so I set up a photo studio, because that was when you developed film and you printed it. I mean, it was great fun, actually. And it turned out that it was also toward the end of World War II, and there was a person near develop and print the pictures that the customers would bring in, which turned out to be a serious responsibility, because all we had to work with were war surplus chemicals and paper. And sometimes they did what they should do, but sometimes they didn't. So that was fun. There was another project when a school class would go from New Bedford to Boston on a field trip, and I'd take lots of pictures with a old box camera, and then print up some and be able to sell those to other students.
So you've been an entrepreneur for a very long time. So I want to talk about your experience in San Diego and the change that has happened to the city in the 60 years that you've been here. A lot of people hold San Diego as an example of the knowledge-based economy, shifting from a small city that was focused on fishing and agriculture and other industries to now one that has a vibrant university, research alongside private industry together. So can you just share with us your observations on the connections between universities, research institutions, and the economy and health of cities?
Yeah. Well, when we came out, I think San Diego had a very strong military presence, had some industry and defense projects, and mostly retired people, pretty much. And the Salk Institute was here, Scripps Research, and of course the university was very new when we came out. The growth of the university, I think, has been really what's caused major changes here. It was only when it came perhaps a few hundred students. Now it's up to 40 some odd thousand. You've probably seen some big towers across the road, student dormitories, a lot of activities going on. But the fact that there were both faculty and now students being trained in very inquisitive questions, some starting companies, I think that just made a huge difference. And so in the case of Linkabit and then Qualcomm, with Linkabit, I think some people have estimated about 100 companies spun out after I left. And with Qualcomm, we've attracted lots of other businesses to come here to be in the wireless area. And so that's built up. And of course, biotech with the university and the hospital and Salk, that whole area has also built up very strongly, again, because of having a major hospital associated with the university. And so it just makes a huge difference to have that kind of intellectual drive, interest, and of course, both students and faculty getting interested in the larger community and accomplishing a lot there.
Yeah, and as Jackie mentioned, you've been very involved philanthropically in supporting a lot of these research institutions. And as you look at the landscape today and all the challenges that research institutions, higher education is facing, particularly with changes in funding, what do you see as the future for research institutions like Salk? How can they navigate these waters? What's the role for philanthropy? What's the role for private industry? And what is the role for the federal government?
Well, I hope the federal government comes back to its senses at some point. Of all the groups to be attacking education and the institutions of higher learning, it's just nonsensical. I mean, there are other nonsensical things too, like climate issues and so on. But that's a particularly bad approach. Yes, you can make up for some of that with philanthropy, and I think that's important. Salk, where I was chairman for a while, a good part of that is supported philanthropically, but also a good part was supported federally. And so now, with the different institutions, including the university, it's slowing down growth. There's been at least one medical building I was familiar with that they had to stop even though there was already a hole in the ground. That interferes with all kinds of progress that could be achieved, and certainly on the health side, improvements. And so philanthropy can obviously play a difference. Corporations have to, by the way, get more involved with philanthropy. There are some that are very actively involved and others. And when I've talked with executives at companies, they often say, well, I've got to, if they're public, I have to worry about my shareholders. And the argument I always used, if a shareholder would approach me, although none ever did actually, because we were always philanthropic at Linkabit and then at Qualcomm, that you have employees that are very valuable. They want to enjoy the community, be proud of the company's role in the community as well. And so any investment that you make philanthropically that pay off with happier employee base, because the most expensive thing would be to lose a valued employee, that really makes sense even for the shareholders. But overall, it's just important for all of us to be seeing what we might be able to do. Unfortunately, of course, we have all kinds of conflicts because right now there's so much pressure on food support, housing, so many problems we have to deal with that the government's backed away from in addition to the universities, that it's hard to think through where best to spend money. So a food bank is obviously very, very important at this point for many, many people.
Yeah. When you were CEO at Qualcomm, you'd come from, you were a scientist, you were an academic, you were a researcher. Corporations like Bell Labs, IBM, RCA, all had these great research divisions. When you were CEO at Qualcomm, how did you think about investing in research, and how do you think corporations more generally themselves could be more active in supporting research? Well,
most corporations, again, you do have to look at where you're going with your business, with your products, and be doing things that are more focused on the next 5 years. Whereas the university research, you really want to have a much broader point of view. But having said that, you can still accomplish quite a bit of research at university. So with Qualcomm, for example, we always had 20% of our revenues going to R&D. There are other very large companies right now, and I won't mention fruit names, but they put in a much lower percentage of their revenue into R&D. And so I think that's important because, again, there's lots to be done. Right now, it's a little bit scary in that we're coming into this new age of artificial intelligence. That requires huge capital investments. And if you make those huge capital investments there, you're still doing some R&D, but much of the funds that are available might be going elsewhere. And so I think that's going to have certainly a long-term payoff. When I say long-term, actually, I used to think with cell phones that they would have a pretty major impact. But in fact, any transition usually takes a decade or so before it sinks in, some of them 2 decades, et cetera, before you find out how to best use them and how it might affect productivity. And I think with AI and AI plus robotics, smart machines, that's going to happen sooner. So I think we have a situation where within the next decade, there's going to be major changes. It, however, also raises then the other problems. I think many employees in a whole variety of different areas are feeling very insecure. You know, is their job going to exist in a year or 2 or 3 years? And how should they prepare for that? And of course, even students at the universities these days, what field should they be going into? With the students, it's easier. Just get a good basic education that you can then apply to almost anything, and that will help. With the insecurity and the workforce impact, we just need to be paying much more attention than has been paid so far to our economy, to our planning, our financial planning. We don't want all the results of this increased productivity only go to the people that own the data centers and the machinery. We want that to get spread much more equally, and the increased productivity should get spread more equally. And so I think we all have a challenge in front of us. I think most likely if things continue in the direction they're going, we'll probably all look forward to a shorter work week. Because again, share the jobs as well as you can. And, but the other aspect, very positive, if you have a shorter work week, you have more time, how should you end up using that time? And so I think that there's going to be not just additional cultural activities around the city, but a lot more emphasis on education in a broad sense, because you want to prepare for all kinds of activities that you, in the time you'll have in the future.
Well, yes, I was going to end by asking you about your thoughts on AI, because you have lived through so many revolutions, telecommunications, internet revolution. When you think about the future, what do you see in terms of policy, things that we may have to do to address AI, and particularly those that may be displaced and the like by the increased robotics?
Yeah, well, again, combining AI with robots and, of course, drones, some good things, some great things can come out of that. And so I do think our productivity is going to go up. It's going to affect just about every part of our lives, or every different employment. And then, again, the main question is how to make use of that productivity increase. If productivity goes up 5 or 10% over a decade or more, then how should that get divided up? And so providing, obviously, much better financial floors for everybody will be an important aspect. Building up our health systems, and by the way, the AI will help us do that with hopefully lower increasing costs per patient, or not even patient, for helping us be healthy at home. And so there's a lot of good things that are going to come out of this, but we're going to have to do some planning on that. And of course, there's going to be, as with any technology, both positive and negative things happening. You can already see that in Ukraine with the drones now getting more artificial intelligence in them and being very destructive. And so we're going to be going through a balancing act going forward. And we just have to, again, have good educational systems, prepare
that. But I think we have some time for some questions. I might ask you one last one, which is, as a historian, I've been worrying about AI. I worry about museums and libraries, which seem to be receiving less support and less visitation. But you just gave me a very hopeful vision of people having more time wanting to visit these places and invest in them. So on the whole, when you think out 10, 15 years, are you hopeful for the future with AI, or are you more worried than hopeful?
I suspect we're going to have a dip or so. It may, with all the money being invested, there may be a hiccup coming along. But overall, I think it's going to end up being, if we treat it properly, a better life for most people.
Great.
The agency and to get awards and get some progress payments. And so that was a good way to be able to start companies. With Qualcomm, I thought, well, probably we'll do the same thing the first several years with the government, but the procurement had changed dramatically. And so more than open to having a new idea and coming back. So the government can play a role in this as well. As if we begin to support NIH and others properly. On starting a company, it's a different world, but change opens up all kinds of possibilities. And so each change means that there's something new that could be done, and one should just focus in on that, be open to it, think about it, talk with people, get a feeling for what might be needed, and then try to run with it.
That's great. What about for philanthropy? Oh, there's a question over there. And I think last question. Oh, we'll get one more. Oh, there's actually several over there. How much time do we have, Elizabeth?
I'm Tom Klein. I'm a member's spouse. This is a member over here. You've been an entrepreneur for a long time, and during that time, taxes has gone down significantly. I remember my childhood, but my father's taxes, the upper bracket was like 70 or 80%, I think, that he paid, and there was a lot of prosperity. And you mentioned philanthropy, but I didn't hear any mention of taxes, and I'd sort of like to know how a businessman now sees the present tax environment. We have a guy approaching being a trillionaire who owns more than the bottom 50% of his country that's allowed him to make that much money. But it seemed to me, isn't part of the problem we have now isn't related to the whole attitude in this country about taxes, that people making money and doing things say they're destructive. Well, they're not necessarily destructive. They're sort of essential, actually, to maintain a middle class. And I'd just like to hear a few words of what your perspective on taxes are. Thanks.
Well, income inequality, I think, is a very major problem in the country, in the world, a number of countries. And that does affect the way people feel and their ability to, in fact, lead a happy life and think that their children will have a better life than they've had. And so I think that needs to be dealt with. A tax policy is certainly a way to do it. Unfortunately, with taxes, if you have a party that reduces taxes, it's always hard to then go ahead and raise taxes because there's always an objection. Now, if you explain it to the nation that our deficits are getting completely unwieldy, maybe you can get that through, but most politicians don't want to take a chance on a tax increase. What I've been suggesting, since we have a number of very wealthy people, and that wealth is often tied up in their assets of perhaps stock that's become very, very valuable. And rather than cashing in that stock and getting money from the sale of it and paying a tax on that sale, capital gains tax, most people just borrow against that and get a very low interest rate because there's basically no danger whoever's the company lending it to them will meet. And so I've actually suggested that nothing's happened yet, but at least a little discussion, suggested to a few significant politicians. But anyway, setting up a tax on the money borrowed against very valuable assets, rather than giving, by the way, a discount on the interest, put a significant tax. I think that would perhaps be a way with a new tax to get something happening. Of course, value-added taxes are being discussed quite a bit. I prefer to see something a bit more progressive than that, but that's could very well be the next step that's happening here. Raising tax rates on the corporations back up just got lowered. I mean, there's all types of things. It's just political will that's needed, and that political will comes from enough people getting upset and letting their feelings be known. And I think there is a direction, that is slowly happening. The last election, we saw some of that. We'll see where this is all going.
Great. I think we have one more question. No time. Okay. Great. I think we're good. Yeah.
All right, well, let's thank Dr. Jacobs one last time. All right, let's continue with our next speaker. And our next speaker today is newly inducted APS member Kimberly Prather, who was elected to the Society in 2022. Dr. Prather is the Distinguished Chair in Atmospheric Chemistry of Scripps Institution of Oceanography and a Distinguished Professor also in the Department of Chemistry, University of California, San Diego. She's also the founding director of the NSF Center for Aerosol Impacts on Chemistry and the Environment. Now, you heard a little bit about Dr. Prather's research when she was inducted, but from a chemist's perspective, I don't mind saying it again. Dr. Prather's work centers around aerosols, devising an aerosol time-of-flight mass spectrometer to examine both the health effects of ultrafine particles and the exhaust particles from heavy-duty gasoline and diesel vehicles. Her research, which demonstrated that aerosols travel well into the atmosphere before they're frozen and returned to Earth, became critical to understanding the aerosol transmission in COVID. More generally, her work transformed how we think about aerosols and their impacts on air quality, climate, and human health. Dr. Prather is a member of the National Academy of Engineering, the American Academy of Arts and Sciences, and the National Academy of Sciences. Kim, please come up.
Okay, well, thank you. Thank you for the introduction, and thank you for inviting me to be here in front of this esteemed audience and to go after someone so esteemed as Dr. Jacobs is a tough act to follow, but I will do my best. So first I have to figure out the clicker, but I hopefully will get that. Okay, so today I'm going to talk about some actually local research. I've done research sort of all around the world, but ran into a problem here in San Diego at the US-Mexico border that has been here since the 30s, so about 100 years, and it's been being ignored. And so I'll give you a little bit of background on what sort of motivated this work. I've always worked on air pollution. When I became a professor, I was very interested in doing things that helped society. And in particular, aerosols. And at that time, people didn't know what an aerosol was. They thought it was the stuff that comes out of a spray can. But thanks to COVID, we've learned they do so much more. And so, and you can see them. You know, they're visible, as is shown in this picture taken during the San Diego wildfires in 2007, I believe. They are the #1 exposure route. We hear a lot more about being exposed to pollutants through water and soil, and far less about the air, even though we take about 20,000 breaths a day. I counted. So basically, the latest estimates are somewhere between as many as 9 million extra deaths a year worldwide. It's more than HIV, malaria, and tuberculosis combined, and 90% of the world is breathing unhealthy air. So there's many health effects. The thing about aerosols that was intriguing to me is when you inhale them, they're like a transport mechanism to get things to every region of your body. There is not an organ that is spared, including your brain, and some of the most recent health effects have been linked with dementia. And so, you know, there's just a huge amount of work showing how important air pollution is and how much it affects your health, but we know very little, especially about the things that I'm going to talk about today. So the challenges are increasing. We have standard air pollutants we measure. You hear about, when you hear the air is clean, you hear about ozone usually, NOx, sulfur dioxide. But basically, as our planet continues to increase in people, there's also many more pollutants that are getting out, as I'll talk about in a second. And so, you know, the ocean's changing, the water's changing, the air's changing due to wildfires, burning things that have never been burned and released into the atmosphere before. And so, you know, things are just getting much more challenging to deal with and address. And a little hint, I will talk about the water connection to air, which is a new one that we've uncovered in the last year or so. So emerging chemical, we call them emerging pollutants, but they're both chemical and biological. I wrote an editorial for Science magazine this year because I kept getting questions from people. I get email ever since COVID. I was the one that convinced Dr. Fauci that the virus was airborne. And so basically, I get questions all the time from the public. And they kept, especially after these fires in LA, people kept saying, is the air safe to breathe? Is it safe for me to go out? Is it safe for my kids to return to school? And the one thing you can look at is the air quality index. You all have that. You see it with your weather maps on your phone. The problem is during the LA wildfires, it went a little wonky because the air looked clean because the pollutants had blown out over the sea, some of them, the ones you can see, the particles. But the toxic gases remained, and that's what I will talk a lot about today is how do we deal with these new pollutants? No one's even measuring them. They don't really want to measure them because I think if they measure them, they are now responsible for protecting people from them and saying what the health effects are. That's the skeptical side, but I've got quite a bit of evidence to back that up. The challenges are increasing, as was mentioned earlier, due to current governmental decisions to roll back regulations on these pollutants. So not only are we not measuring the new ones, or the newer ones, we are now stopping measuring the old ones. And so this is a very daunting task to think about how to protect people's health on a global scale. So a little bit of background on me. As I say, began my career looking at aerosols. Aerosols, as I say, are very visible, but the one big lesson is we share the same air. And aerosols can travel all the way around the globe. It takes about 2 weeks. That's how I got sucked into the COVID pandemic. I had a reporter ask me, do I think aerosols can go 6 feet? And I thought of this. On water supply as well as human health. And there's many examples, biological examples that we've been focusing on a lot from a health perspective are things like viruses and bacteria. So in 2010, I became the director of the National Science Foundation Center for Aerosol Impacts on Chemistry of the Environment, or CASE. And I continued to direct that for 14 years. I still direct it, but now the Center for Chemical Innovation part has been removed. But we still continue to work on this one problem, which has to do with how is the ocean affecting our health? And people don't really think about that. We know a lot more about dust, and we study dust coming out of deserts and all those different things, but nobody thought about the sea spray. They thought it was just salt. Out of the ocean. As that video shows, aerosols from humans are everywhere, so it's almost impossible to go anywhere. You can't go anywhere on this earth and just study the ocean. So we moved it into the lab for this reason. So you might say, how hard is that? It was really hard, but it was really worth it. And, you know, basically it's not just sodium chloride, which is what people have been using to mimic the ocean forever. And so a drop of seawater contains all signs of life. The ocean produces over half of the oxygen we breathe. So it's like a forest underwater, and there's every component of life in that ocean. And so how do we replicate that in the lab? We work with oceanographers, we worked with marine biologists. This is the beauty of about, suddenly do. We built, this is our current incarnation, and I invite people, if they would like to visit at some point. We have this massive, the world's, I think, largest ocean atmosphere simulator that just got launched in 2021, I believe. It's called SOARS. And this allows us to not just break waves, but we have hurricane force winds. We can make sea ice. It's 36,000 gallons of seawater, and we can control it. And so we can actually do sort of all the things that you would like to study outdoors, indoors. So this shows what's called the hydraulics lab at Scripps Institution of Oceanography. And I'll just show you a quick peek. The blue is the wind tunnel. And if you look really quickly, you'll see waves breaking right below that plastic glass that's on there, or plastic top. This is my students with their instruments making measurements. So it's kind of like doing a field study in the real world. And so basically, it's a massive undertaking. People come from all over the world. It's now a facility that users can do the studies, and there's the magical waves themselves. So I talk about bubbles a lot. I talk about aerosols a lot, and this is the direct link to the point of this talk. Basically, that white stuff, those are all bubbles, and these waves have become, the key. There's a million ways to make sea spray incorrectly. There's only one way to make it correctly, like a breaking wave in the real ocean, and we wanted to simulate the real world, exactly. We didn't want to have any, so that we could actually use our lab results to explain. So, here's a breaking wave in the SOARS, and you see all those bubbles, and when those bubbles rupture, you can see there's two mechanisms that take off. There's a film cap that ruptures and the spray goes off, and then there's a jet that comes up out of the center that also releases aerosols that have very, very different compositions, as we were able to show. And once you get it right, which took us 3 years, basically you start to see all kinds of biology. You see little things that look almost cellular, you see bacteria with phage inside of them, you see droplets with bacteria. Because the bacteria and all the organic goo, if you will, the proteins, things don't really want to be in the water, so they concentrate on this thin skin called the sea surface microlayer. And when those bubbles rupture, they get released into the air. And that's key for my talk today. So, on the left shows the work we did to sort of understand the cycling of biology and how, if you induce a phytoplankton bloom, if you induce a toxic bloom, how does that affect the air? And so we did this, and we worked really hard to understand what gets out. And I will tell you, we did it through genomic sequencing. We're now doing RNA sequencing to look at the viruses. Only a certain fraction gets out, and it's very, very specific. But what about if you're in the real world, like here in San Diego, near the US-Mexico border, hint, hint. This just shows a massive amount of polluted water that is going into the ocean every day. Up to 80 million gallons of wastewater each day goes into our Pacific Ocean, yes, here in California. So what gets out? Which pollutants get out from the water? Which pathogens get out? And then how far do they go? So this had long been considered a water problem, an ocean, a beach problem. Just don't go to the beach that day. Just don't go surfing that day. But in fact, once it hits the air, it can travel all the way across San Diego. As I showed in the very first movie, it can travel very, very long distances. So now the exposure route and the exposure process becomes important for a lot more people than just those living at the border, which turns out to be important because just those living at the border had been being largely ignored. This is a massive environmental justice issue. So basically, we've been doing measurements there, looking at sort of the microbes that get out of the ocean. And this last year, in 2024, this is the Imperial Beach Pier, which is the most southern city along our coast. This is one of my students. And there started to be coverage, finally, because it's kind of been a hidden problem, which is shocking to me. And so basically, they kept talking about how far does the ocean go? Who's going to be affected if they go to the beach? And I basically came along and said, but you inhale more air than anything, and we don't filter our air. We filter our water before we drink it, but we don't filter our air before we breathe it. Go figure. And so it's, basically we can shut down the beach when the water is polluted, but we don't tell people not to breathe. So it's a little catchy. So this shows some pictures of the area. This region is called the Tijuana River Estuary. It's right at the border, as you can see in this picture. 3/4 of the world lives within 30 miles of the ocean, very reachable by anything that would get out of that water. The bottom left-hand figure shows the pollution that goes into the ocean. And we did a study. It started in 2017 with the oceanographers at Scripps. It was just, we piggybacked, and this is where philanthropy let us launch into this new area, where we looked at where does that pollution go? Where do sewage outfalls go? Where does pollution that runs into the ocean go? And people just thought, the ocean's vast. You've ever heard the term solution is the dilution? No. So dilution is the solution to pollution, right? No, it is not. It can be if that pollution goes out into the ocean, but what we were able to show using a pink fluorescent dye was that if it gets trapped in the surf zone, think waves, think bubbles, those get launched, and we detected those aerosols all over San Diego County. So this shows a zoom out of that whole region, shows right where the river is going in. This is pictures of my students doing measurements in this area. We published a paper, which I'm not going to spend much time on, in 2023, which kind of woke people up, I would say, because we showed that up to 3/4 of the bacteria you breathe in the air in Imperial Beach come from that polluted water. And, basically nobody had even thought of it. We did it through genomic sequencing. So it was tracing, it was directly linked. Nobody could argue. They tried, but we were right on that one. Then we went further and we said, what about the chemicals? There's a lot of chemicals in wastewater. This is a combination of raw sewage and industrial waste. So we found drugs, illegal and not illegal. We found methamphetamine, cocaine, heroin, airborne, in the air, in that region. We sampled it all up and down the coast, and we could detect smaller and smaller amounts as you moved away from the river. Again, this was in March. Last September, we took a little pivot. We decided we'd been going during the rainy season when at that point there's millions, there can be more than 1 billion gallons of water in one day that flows through that river. 1 billion. And so we kept going during the rainy season when it's very dilute. So we decided, let's go when it's dry season. Dry season means in California, there should be no water. It should not be flowing. And so we heard that the community was squawking very loud, that their lungs were burning, they were having heart problems, they were having mental problems, sleep problems. They were screaming, really, and it stunk. It stinks beyond your worst imagination. And they were not being heard. So we decided to go down. We went in August, as I say, during dry season. At this point, we get there, it's supposed to be dry. It's not a river. It's not a river. It's wastewater. 40 to 80 million gallons were flowing, only at night, secret dumping. So, basically industries on the other side are dumping in there at night, and they only turn on the flow. They're regulating the flow on the Mexican side, and they turn it on only at night. And the odor reports were shooting out the roof. And so at this point, I study aerosols. Aerosols don't smell, but gases do. So we said, what are the gases? And this was a pivot for us. So we went, this is kind of a little bit busy, but just to make the point, we went to the coast. where we've always gone. We put our mobile lab there, we started making measurements, didn't see much. This shows when the winds were blowing off the ocean, the blue part, strong winds off the ocean, no hydrogen sulfide gas is the key tracer for sewage. That's the stinky rotten egg smell. It's also a toxic gas. It was the first nerve agent used during World War I. And so basically, you see that when the winds aren't very strong, so closer to the center, you see red. That's high concentrations of hydrogen sulfide, the highest concentrations of hydrogen sulfide. And it's coming from land. So we talked, my students were wise. They talked to the community. The community said, what are you doing? Why are you at the coast? We'll always make our measurements at the coast. They said, the smells are over here, along the river. Who would think that a river could, I didn't think a river could be putting out more stuff. So we moved over to the river, and we talked to the community and found out all of their issues. They visited us every day to tell us their issues. And so this just shows a map of the area where we were doing our sampling. It shows, basically we started at Border Field, which you see is down by the border. And the key point is what is now referred to as a hot spot. And it's zoomed in on there, and you see this very telltale white foam. And so this you can see is very far inland, but it's the river that is flowing, and then ultimately, I showed you, dumps into the ocean. So this is the spot. It's not the whole river that causes the problems we've learned, surprisingly. This was a huge discovery at the time. There is a point where the wastewater is coming along, and it gets forced through these pipes to get under a road. And when that happens, you get all this turbulence. And that turbulence are those wonderful bubbles that I've been talking about. That basically leads to nearly 100% transfer of aerosols, as well as these toxic gases that are dissolved in the river. There's such a big foam patch there that you can see it in the bottom right-hand corner from space. That is not normal, and certainly not something we would expect in the United States, for sure in California. So it's a shocker. So basically, hopefully this shows, whoops. Let me see, I want you to see the source. It worked before. Do you guys know why the video's not working? I hear it. Oh, you could see it. Oh, I can't see it. Whoopsie, sorry. Okay, there you go. Oh, you can see it. Okay, I can't. Okay, I'll believe you. All right, so basically this just shows the turbulent spot and why it's turbulent. And then you see as you zoom out, you can see all the foam. And this is the stinkiest air that burns your lungs and gives you a headache that doesn't go away for days, and also gives you skin rashes. So we wear, as you see in the next slide, my students all wear biohazard suits anytime we're near this spot. And so we went to the river, we sampled river water. We also continued to sample the ocean because it's still some source because the river water goes in there. And what we did was we collected water samples everywhere and air samples everywhere to compare, where is this coming from? And so basically, hydrogen sulfide, coming back to that, I'd never measured hydrogen sulfide in my life, but this turned out to be a good thing to be measuring. We went to that hot spot. The nearest neighborhood is called Nestor, and it's in San Diego. And this is where the community was really complaining. Most of the complaints came from there. You can see the red lines, that's hydrogen sulfide. The spikes are at night. To calibrate you, they reach over 4,000 ppb. What's typical urban air? Less than 1 ppb. At the river, where people are horseback riding and birding, we detected over 20,000 ppb. And no one had said a word. So we started this on September 1st. September 2nd through 4th, we saw it started rising every night, only at night. It actually reacts away during the day, little known point, but the big source is at night. So September 5th, we decided we better tell the public health department. We had a meeting with the task force. I presented the results. They said nothing. They just looked at me. Next day, people woke up and were very distraught. Community members were there, and they're like, I can't believe they didn't say a word. They're still not going to help us. So we held a press conference and decided, and I had no idea, by the way, what we were getting into, to be honest with you. I'd never done it. The mayor says, Mayor Paloma Aguirre, she says, let's hold a press conference with your data. I'm like, okay, whatever it takes. At this point, I was so attached to this community. And movie scene, and there's just all these, cameras and, microphones shoved in my face as soon as I get out of the car. I tell you, I had no idea what I was getting into, but I went along with it and showed our data, and we alerted the public since Others were not going to do so. This is September 9th, 2024. Our theory at this point was it's the turbulence. It's when the river's flowing that's a problem. If we could cut that turbulence, it should go down, right? So, surprise, surprise, the next day, they stopped the river. They turned off the river. I keep telling me on my headstone it's gonna say she stopped a river. So yeah, they stopped the river. And basically, again, the wastewater, they diverted it, they kept it in Mexico, dumped it on the other side of the border. And so what do you think happened to the hydrogen sulfide? They helped us do the world's best atmospheric chemistry experiment ever. They thought they were tricking us, but they just did this. Like if I'd asked them, could you, run the river and then turn it off so we can see if that's the problem? They would never have done it, but they did it. And so the really cool thing, and probably one of the best, am I getting behind? I better move fast? Okay, she told me 25. She told me 25. Okay. I'm sorry, I'll go fast. So I'm not going fast. But anyway, this is the coolest figure of my entire career. These are the odor complaints versus the hydrogen sulfide. Our correlation, 1 would be perfect, 0.92 is pretty darn perfect. So we validated the community voices, and they were definitely thrilled. And this is, again, probably the figure that I'm the most proud of. It's been labeled the number 2 most endangered river. It is the largest current public health crisis in the United States. The impacts It's like a beautiful thing you can do when everybody works together and when you work with the community, and we did that. Now they have toxic gas signs just like toxic beach signs, which has never happened anywhere else in the US. This is the foam. This is just recent. It was 10 feet deep. We couldn't sample the river. Again, this is not normal, except in India. All their rivers and their lakes for the same reasons. And so I'm going through fast, but I just want to make the point. This is a local problem. We're figuring out how to deal with it. We're sampling like crazy. We have not stopped. The community keeps saying, please don't leave. We're not leaving as long as we can afford to stay there. But 80 to 90% of all wastewater is discharged and dirty, and it affects everyone globally. So big story. We are pushing towards doing airborne surveillance of wastewater and using machine learning to sort of look at how we can link these different aerosols, the viruses, the bacteria, fungal spores, look at the global circulation like we do for other types of aerosols, and link that with health. I just want to quickly thank those that have done this work. There's a big crew behind me, or I would not be standing here. And I want to make a comment that, we were allowed to keep going during this crazy government situation with funding. Our federal funding has all dried up, and we had philanthropy. Thank God, because we didn't leave. They thought we were leaving. They were waiting for us to leave to turn back on the river, and we are still there. So with that, thank you for listening, and thank you.
Thanks so much, Kane. I think we'll take one question.
Thank you
Quick
very
question.
much. Rich Schiffer in Indiana. Thank you for terrifying us.
We got it under control.
It sounds like we're suggesting we all leave immediately and go to other parts of the country. On the other hand, there's a solution. We just apparently stop the ocean.
The river. The solution is to not put the stuff in the river in the first place. There you go. That's the solution. Source control is always the first rule, and for some reason, that's not happening. So no, it's much easier just to not dump it in the first place. Yep. Okay. Thank you. Thank you.
Thanks, Kim. That was fantastic. At this point, let me say I live by the ocean. We're now going to take a break. I think we're going to take a 15-minute break. So let's get back here at 10 minutes to 3. Snacks and refreshments are available on the Flagstone veranda. And if you're interested in recording a lightning talk, which we encourage you all to do for the society, please visit our Director of Press, who's in the La Jolla foyer, to sign up for that. And we'll see you in 15 minutes.
Testing one, testing two. Good morning, everybody. Testing one, testing two. Testing one, testing two. Testing one, two. Testing one, testing two. Testing.
we can all reconvene. If everyone can please take their seats, and maybe we could close those doors. Wonderful. Our next speaker is Jolie Proudfit, Director of California Indian Culture and Sovereignty Center and Department Chair and Professor of American Indian Studies at California State University, San Marcos. A citizen of Payam Kowisham, or Luisaya Nyo, and Tongva nations of Southern California, and I apologize for my mispronunciations. Dr. Proudfit's work examines contemporary and historic politics and policies impacting the Native American community. She's a vocal advocate for positive legal change. Dr. Proudfit owns Nakmayam Communications, a Californian Indian-owned and operated public relations agency that promotes socially conscious marketing as well as consumer and cultural education. In 2016, Dr. Proudfit was appointed to the National Advisory Council on Indian Education by Barack Obama. Her talk today is titled Grounding in Place, Kumeyaay and Neighboring Nations and the Philosophy of Responsibility. Please join me in welcoming Jolie Proudfit.
Miriam, Natong Dr. Jolie Proudfit, Yaka Lusenyo Pankowisham, and Tongva. Good afternoon, and thank you for welcoming me into your space. You are an impressive group of individuals. And I stand before you, rooted in the ancestral memory and knowledges of my Pankowisham and Tongva bloodlines. I am the daughter of Helen Infante Roby, and my maternal grandmothers are Lupe Grijalva Guerrero, Refugio Flores Grijalva Zuniga, Candelaria Flores, Juana Apish, Pablo Apish, and it has been said that it was in Pablo Apish's home that the Treaty of Temecula was signed, which would have provided 7.5 million acres to the California tribes, but that did not happen. The land was not given to us. Those treaties were hidden in a vault. We gather today in a place many of you know as San Diego. Before anything else, I honor the Kumeyaay Nation, the host nation of this land that we stand today. The Kumeyaay and their Ipai Tipai homelands have lived, governed, created, and cared for this place since time immemorial. I speak as a Pankowisham and Tongva woman from neighboring homelands. I honor the nations of this region, the Pankowisham, our bands, the Palma, Pachanga, Rincon, Saboba peoples, among the Kumeyaay nations, Inaha, Casmet, Barona, Capitan Grande, Iyawap, Hamul, La Posta, Manzanita, Mesa Grande, San Pascual, Santa Isabel, Sequan, Viejas, along with the Kumeyaay relatives across the imposed border. I also honor the Los Quiotes people and our Kuya and Cupeño relatives whose homelands intersect with this region. Years ago, Vine Deloria Jr., my mentor and teacher, taught me that philosophy is not just written. It is lived through our relationships with each other, with history, and with the land itself. Today I offer three things: a grounding in where we are, a truth-telling about what happened here, and an invitation to be ethical and in an ethical relationship with this place and its people. But I have to say first, I'm deeply, honored to be here today when you inducted Dr. Dean Professor Stacy Leeds. I had not met her before, but one of my professors, Devin Mehesu, has always spoken so highly of you. And it's very rare for Native women to be in spaces and places like this, but it's becoming less rare. So my heart is very warm to be here, and thank you for recognizing one of our women. This is not to in any way set aside any of your accomplishments. We are all in relationship. The previous speaker is an indigenous warrior for all of us, and the land and the waters and the air we breathe. And this is how we must see ourselves, in relationship to one another, to the air, to the water, to the land. This is not just poetry, this is survival. And it's also good to see and finally meet Dr. Jacobs. I had the good fortune of knowing his son very well, Jeff Jacobs. We share the same birthday, Jeff and I and Dr. Seuss. But I always love to find relationship. It humanizes us. There's so many things that we look to separate ourselves. And so when you see someone and you say, my husband is best friends with Skipper, who is best friends with your son, we find a relative. And in that way, we are all related. To be grounded in place is to understand that you are not separate from the land beneath your feet. Philosophy, Michael Connolly Mikwish teaches this responsibility flows from ihun, heart and spirit. Everything possesses ihun, the rocks, the water, our oak trees, the mountains, the animals. All are relatives, all require care. When you are grounded in place, you understand that you have entered into kinship, and kinship demands reciprocity. Connolly, Mikwish, his work in Kumeyaay cosmology reveals a worldview where humans are not the center of creation, but one part of an interconnected web of relationships. Kumeyaay cosmology teaches that the universe operates through balance and reciprocity. That mountains are ancestors, that water has consciousness, that plants are relatives who choose to share with you, you cannot exploit. You can only participate in relationship. This is not a metaphor. This is philosophy as practice, a way of being that has sustained indigenous peoples and these ecosystems for thousands of years. And this philosophy is more urgent now than it has ever been. We face climate catastrophe, mass extinction, megafires, and collapsing water systems. We cannot survive and language revitalization leader has spent decades demonstrating that traditional ecological knowledge is not primitive. It is sophisticated science, tested over millennia. His work spans fire management, which prevented catastrophic wildfires and promoted biodiversity, and Kumeyaay language immersion programs that ensured the survival of Kumeyaay ways of knowing. Language and land are inseparable. You cannot practice traditional fire management without the Kumeyaay words that encode when, where, and how to burn. Dr. Rodriguez's work shows that revitalizing language is revitalizing relationship with the land itself. We here in California have either been touched by fire will be touched by fire. Every home I've ever owned in every county I've ever lived, I have been evacuated. This last fire in January burned our home in Pasadena on our Tongva homelands. My Tongva tribe is non-federally recognized. My Luiseño tribe is federally recognized. And so what happens when the little land that your tribe has, whether federally recognized or not, what happens when it all burns? What happens when your burial sites all burn? These are serious questions we have to face, have faced, and will be facing. Before this region bore Spanish and English names, it was known through Kumeyaay language, a naming system that encoded ecological knowledge, seasonal patterns, and ancestral memory. What settlers renamed La Jolla was Matkulahui, land of holes, referring to sea caves carved by the ocean over millennia. San Diego sits at the heart of villages like Kusai, near Old Town, Tasir at the Big Water, near the bay, inland Hapai water coming down, marked springs near Alpine, and Pamo stood in Mission Valley, where multiple echo zones converged. Each name teaches us that Kumeyaay people did not see themselves as separate from the land. They were the land. They are the land. Their villages were expressions of belonging, carefully situated where water, plants, animals, and people could thrive together. When we use only colonial names, we erase this knowledge. When we restore Kumeyaay names, we restore relationship. This knowledge matters now more than ever. Since time immemorial, indigenous peoples maintain California's ecosystems in balance. This wasn't luck, this was science, practiced with the understanding that human survival depends on ecosystems and healthy ecosystems. To understand our current crisis, we must understand what we have lost. Genocide didn't just kill people, it severed the relationship that kept these ecosystems alive. And yes, I use the term genocide, a state-sanctioned genocide, one that this governor has finally apologized for. Between 1846 and 1873, California indigenous population declined from approximately 150,000, and we believe that's a low estimate, to fewer than 30,000. This was not disease, this was policy. Every indigenous person killed represented generations of knowledges destroyed, relationships severed, responsibilities abandoned. In 1850, California passed the Act for the Government and Protection of Indians. Be wary when policies have the word protection in them. A law that made slavery legal for California Indians under another name. Indigenous people, including children, could be indentured for vagrancy. Children were taken from families and bound to white settlers. California became a slave state for indigenous peoples. In fact, if you know the history of California, much of it is based on a slave economy and on a prison economy. California paid bounties for indigenous scalps. Between 1850 and 1861, the state reimbursed militias over $1.5 million for expeditions to kill indigenous people. Entire villages were destroyed, women and children were murdered. These were not isolated incidents. They were coordinated campaigns to eliminate California Native peoples and seize our land. In 1851, 3 federal agents negotiated 18 treaties that would have set aside 7.5 million acres of California Indian reservations. Remember the treaty signed on my 5th great-grandfather's kitchen table. California's white settlers protested. They wanted all the land. In 1852, the U.S. Senate held a secret session and rejected all 18 treaties. The treaties were hidden for over 50 years in a vault not revealed until 1905. Indigenous people who had negotiated in good faith, who had moved to designated lands, found themselves landless and without legal protection. The federal government stole treaty promises and abandoned California Indians to genocide. And all the California tribes in California exist through executive order, not through treaty. It took until 1944 for the federal government to acknowledge any responsibility. After decades of legal battles, in 1964, California Indians were compensated 47 cents per acre for 64 million acres of stolen land. 47 cents per acre. This was not justice, it was an insult. I remember when my mother received that paycheck. I was born in 1969, and in the early 1970s, when she received our payment, she had 2 children, and we went from sleeping in one bed to having her purchase multiple mattresses. That's what we received for our land. The money came with no land returned, no sovereignty restored, and no acknowledgement of genocide. And yet we are still here. Despite genocide, despite slavery, despite bounties and massacres and stolen treaties, despite 47 cents an acre, we are still here. The Kumeyaay people are still here, speaking their language, practicing their ceremonies, teaching their children. Dr. Stan Rodriguez has been instrumental in Kumeyaay language revitalization and immersion programs around the world. In fact, I almost could not come. I was invited several months ago, and I debated because I had another important event, actually 2 events. Tomorrow I leave for the World Indigenous Peoples Conference in New Zealand to discuss AI and Indigenous communities because this is important. We know that this is important. And the environmental impact on our water, our air, our lands, on all of us, it's very important. But Monday, I had another important event, this past Monday. And this is a fun event. And there's a person that I think everybody in here is of an age that they may know who I'm talking about. But I'm also an edutainer. I really believe in making this information palatable for folks who don't want to hear all the kind of negative policies. I'm a producer on a documentary, Jim Thorpe, Path Lit by Lightning, the greatest athlete who ever lived. And today we sent in our application for a Peabody Award, so hopefully we get it. But Monday I was at Nike headquarters, screening it at Nike headquarters. And I tell you this because it takes all of us to keep history alive. And when you have that level of excellence and those people in our history that make a Native child today smile, we must all do our best to lift them up. Let us not forget the great Jim Thorpe and all his contributions. They are many, but that is why I wasn't sure, and I apologize for the late. Normally I love visuals and to give you lots of images as an edutainer, but I have spent the last 2 weeks in the inside of so many airports during the most challenging travel times, so forgive me for not having visuals for you. But I leave you with the Pacific Ocean. How's that? And some sunshine. When children learn Kumeyaay words for plants, seasons, and fire, they are learning how to be in relationship with place. Language revitalization is ecological restoration. When Kumeyaay fire practitioners return controlled burns to these hillsides, they are not just simply practicing sovereignty, they are sovereignty. When Kumeyaay language teachers say, Matkalahui, I'm Payankawichim and Tongva, not Kumeyaay, so I too have to ask my Kumeyaay cousins for pronunciations. Instead of La Jolla, they are restoring the world. When tribal nations protect water and sacred mountains, they are fulfilling responsibilities they have always held. Indigenous people, it's often been said, protect 80% of the world's remaining biodiversity. This is not coincidence. This is a result of knowledge systems that understand responsibility, that practice reciprocity, and see humans as part of ecosystems. But we cannot do this without collaborations and without all of you. California Indians are now teaching agencies like CAL FIRE how to burn properly. The agencies that once criminalized indigenous burning are learning from those they tried to silence. The knowledge survived, the relationship survived, and the responsibility survived. If we are to survive the next century, heck, if we're going to survive the next election cycle, we must listen and collaborate with indigenous knowledge systems, not appropriate our knowledge, not tokenize our participation, but actually return authority and resources to indigenous nations so we can do what they have always done, care for the land. If you live here, work here, study here, or benefit from being here, you have entered into a relationship with this place. Relationship creates responsibility. This is not guilt, this is not shame, this is recognition that presents an opportunity for obligation. California Indians have maintained their responsibilities despite genocide, despite theft, despite when nearly everything was taken from us. Now the question is, what are your responsibilities? I encourage you to work with the indigenous people around you, whether here, there, or anywhere. Understand the history of what happened to the place that you live on. Support indigenous sovereignty. Land back is not a metaphor, it's a return of land management to those who know how to do it. It is recognizing that climate solutions without indigenous leadership will fail. Defend what remains. When our sacred sites are threatened, stand with us. When indigenous water rights are challenged, support us. When traditional ecological knowledge is dismissed, nostalgia, but real lived responsibility. The kind that changes how you move through the world, how you make decisions, how you relate to the land, and the people whose ancestors has always been here. Kumeyaay philosophy teaches that everything possesses a hun, heart and spirit. The mountains, the water, the oak trees, the soil, the fire, all have a hun. And if you are here, you are part of this place spirit too. The question is not will you be? Will you be the kind that takes without giving back? Or will you be the kind who understands that care is not optional, that if we want to survive the crisis we've created, we must learn responsibility from those who have never forgotten it. This land remembers, the mountains remember who tended them, the waters remember who protected them. California Indian people remember, and we are still here, still practicing responsibility, still offering us knowledge we desperately need. And let me be clear, we are not just surviving, we are leading across this country and across this county. There are 18 tribal reservations in San Diego County, more than any other county in the United States. and at least 14 of them are Kumeyaay homelands. The Kumeyaay Nation today is organized of 13 reservations in what is now San Diego County, and at least 4 more communities just across the imposed border in northern Baja. Statewide, we have 109 federally recognized tribes and dozens more unrecognized nations that hold only 500,000 acres in reservation land and a state of more than 100 million acres of territory. Less than 1/2% of California's land base under tribal control after 2 centuries of theft. Yet on the small fraction of land, California Indian nations are running governments, restoring forests and rivers, rebuilding languages, and protecting ecosystems. So when we say land back, when Kumeyaay people reclaim 1,100 acres, as they did just recently, or 17,000 acres there, we're not talking about nostalgia. We are talking about increasing the tiny percentage of this land that is once again in the hands of those who prove they can care for it. The genocide failed, the theft failed, the erasure failed. We are still here. Kumeyaay, Panguichum, Tongva, and California Indian peoples on both sides of the border, and the numbers themselves now testify to what our elders have always said. We are the past, the present, and the necessary future of this place. Nosholovik uhiyi. My heart is good. Thank you.
Thank you so much, Dr. Proudfit. Do we have some questions?
I figured you guys knew it all.
Sir. Please say your name and where you're from.
I hate to dominate questions. I'm Tom Klein again. I took my 1 year of California history way back in the 60s at UC Berkeley. And what struck me was how localized all those tribals. And you mentioned all these tribes in San Diego. And it occurred to me, how did they coordinate management of the environment if they were all in these very, very dedicated land where they stayed there for generation after generations, but they must have had to coordinate among different tribes to manage like fires and wildlife and so forth. Have we learned anything about how that was done?
Oh, absolutely. And when we say we are all related, it's both philosophical and biological. And so we had to work together. I'm not suggesting that we didn't have conflict, but when it came to the land, there was bartering, there was trade, right? Our cosmology, my Pancowicham ancestors and my Tongva ancestors have a lot in relationship to Hawaiians and to the Maori people because we're coastal people. So there was lots of negotiation from across the seas, but also localized. We see that in some of our languages. So in my language, Miohiam, in one of my languages, Miohiam is hello everyone. To a large group of people. In the Kauai language, which are the desert people like Palm Springs area in inland, it's Mihue, right? So of course we were related, of course we worked together. I'm so glad that you took a class in California Indian history in the 1960s, but it was only recently, as of 2 months ago, that we submitted, and I was one of 3 California Indian scholars that submitted 400 lesson plans to the state of California. This is the first time in the history of California's existence as a state government that they actually paid for some curriculum. So I'm hoping that this type of knowledge will be provided to all of the students in our great state.
One more question?
Is this working? Do I have to push something? We're in San Diego, which is the second name, I guess, this place has. What is the relationship between indigenous culture in this area and Mexican stewardship during the first half of the 19th century, let alone under Spanish stewardship from I think it was 1718 or 1721 when the mission was established. Did these indigenous traditions remain intact without, let's say, without interchange with Spanish and Mexican traditions? In the sense, you present a picture as if they're totally pristine in 1848 when they were under control of other peoples for 150 years, well, marginal control.
And you can say who you are.
Richard Kagan from Philadelphia.
So I had mentioned that there are Kumeyaay, Ipai, Tipai tribes across the border because that's an imposed border, right? And I have to admit that much of the traditional knowledge systems, especially language, is coming from across the border because they've been so isolated and the assimilation policies weren't as strong with them, that we're now looking to our border relatives for much more astronomical knowledge systems, ethnobotany knowledge systems. So our federal government policies did more to hurt our knowledge systems than it did our counterparts across the border. Those relationships are strong. We have ceremonial practices that we continue to conduct. And like I said, I mean, things like language and ethnobotany and plant medicine is really strong with our relatives across the border. Colonialism and California faced really 4 waves of colonization, and you could even say it was more than that if you look at the Jesuits, then the Franciscans, then the Spanish, then the Mexicans, then the Californios, and then the Americans, and now whatever we want to call this today, right? And so this is why we're not interested in blaming or shaming. We're interested in collaborating because we're all related. I am married to a Scottish man, hence the name Proudfit. I thought when I married a Scottish man I was going to get a cool crest like with a lion. No, I got a half a leg with a knee with the lion's head sticking out of it. So my daughter and my husband are not going anywhere. We are all in this together.
Thank you, Dr. Prophet. Wonderful. All right, our final speaker of the day is Eric Topol, the Gary and Mary West Chair of Innovative Medicine at Scripps Research Translational Institute. Eric Topol is an American cardiologist, a scientist, and an author. He's the founder and director of the Scripps Research Translational Institute, a professor of molecular medicine, and executive vice president at Scripps Research Institute, as well as a senior consultant at the Division of Cardiovascular Diseases at Scripps Clinic in La Jolla. He's published 4 best-selling books on the future of medicine, most recently, Superagers, an evidence-based approach to longevity. Given the many superagers in this room, I thought it would be a good idea, since we were in San Diego, to have Dr. Topol come and speak with us. His principal research focus has been on the use of genomic and digital data as well as AI to individualize medicine. Topol was elected to the National Academy of Medicine in 2014, and he was named Doctor of the Decade by the Institute for Scientific Information, being one of the top 10 most cited medical researchers. In 2024, Topol was featured in an inaugural Time 100 Health list of the most influential people in healthcare in the world. His talk today is called Superagers, an evidence-based approach to longevity. Please join me in welcoming Dr. Topol.
Thank you. Thanks very much. Thank you. All right, well, it's great to be with you. Thanks for having me. And I think I would agree there must be a bunch of superagers in this room, so that's great. So what are we talking about? Well, we're going to talk about extending our health span, which I think, is anybody not interested in that here? Okay, just some. And the way we're going to do that is to prevent the major age-related diseases. I'm talking about cancers, cardiovascular disease, and neurodegenerative diseases. So I want to start with a patient of mine who's from here in La Jolla named Lee Rushall. And she is how I open up this book because she is a classic superager. She's 98. She still is an oil painter, has a gallery. She is plugged in with all her friends and social network, and she's never been sick of any significant disease throughout her life. Now, why is this important? Because she's very representative of superagers. People think that this is a genetic story. Well, here's her family history as far as her mother, father, brothers, when they died. Mother 59, father 64, brother 43, and her other brother 75. This is not unusual. We studied 1,400 people, average age of 89, who'd never been sick, on no medications, and we did whole genome sequences. We found very little from their DNA to explain their phenomenal health span, okay? So there's a myth that it's genetics, but actually that's a small contribution, much less than has been expected. And that compares, by the way, Welderly is what we call that study. I wanted that to be the title of the book, but the publisher said nobody knows what that means. So yeah. Then there's the elderly, which are the counterparts who had very similar genomic profiles, and they are the typical people age 65 and older in this country who have at least one, if not more, of these chronic diseases. So we need to flip this elderly to the welderly, and how are we going to do that? Well, just recently in this journal, on the cover is Maria Morera, who was, up until last summer, the oldest human alive. She died in Spain a year ago, August, and before she died, she Okay. Well, she's had the deepest profiling of her biology, her immune system, her gut microbiome, her DNA, as any person over the age of 100 or even 95 in history. And what did they find? Well, her immune system was remarkably youthful, as was her gut microbiome profile. And we're going to get to the immune system being a very essential part of this healthy aging story. Yes, she did have a healthy lifestyle. She didn't smoke. She drank a very minimal amount of alcohol. She even survived COVID when she was 114. So she was a very healthy lady. Supplements. There are no data to support that, okay? And we have, this just keeps going. We're living to 120, old age is over, the pills to end aging. No, none of that is true. None of it. But we do have, on the other hand, a remarkable increase in the science of aging. We've had tremendous investment in biotech, such as, for example, Altos Labs here in San Diego. And they are making big strides to potentially but we're not anywhere close. Now, there's another side to this, which is what I'm trying to get you to buy into, that we can prevent the age-related major diseases in the future. Not only that we can, but we will. And the reason we can do that is because we have, this is an arbitrary circus plot, but we not only have a knowledge about lifestyle plus, not just diet, sleep, exercise, but also many other factors we can get into. The omics, not just DNA, but especially I'll point out the era of the proteomics of proteins, no less the other layers. Already mentioned the gut microbiome and the epigenome. We have drugs and vaccines, and we even have cells to work with to modulate our age-related propensity to diseases. And we have multimodal AI to bring billions of data points on any given individual to integrate that, to predict and prevent. So, to me, the biggest advance in aging science is not that we have all these different shots on goal, like partial epigenetic reprogramming, senolytics to eradicate the senescent cells from our blood, all sorts of ideas out there, rejuvenating our thymus or the ovaries, but rather that we have new metrics of aging. We didn't have a way to have a biologic aging way to quantify that. We do now. We have these molecular clocks. Body-wide aging. The classic one was from Steve Horvath more than a decade ago. Now there's many others. These are mainly focused on the methylation pattern, the side chains of the genome. And they can be done inexpensively, widely, particularly in academic labs. And we also have other ways to get to body-wide aging. But that's not enough, because if you have someone whose actual age is many years younger than their body-wide age, that's not a good sign, but you can't really localize what the problem is. So now we have the big advance of organ aging, and particularly the proteins, the proteome. This was ushered in by Tony Wiscore at Stanford and his colleagues, and now been validated, replicated by many other groups. And the whole point here, this is late 2023, is that we can track the aging of each of our organs and the immune system, which is, of course, not an organ, but a very important system. And all of these studies converge on this point, that if you look at the survival and the health span of people who have marked advantage in those lifespan and health span, there's two clocks that are very important, the brain and the immune system, and they dominate this. And of course, the other organs of the body are important, but it appears that this brain-immune system combo is remarkably powerful. We need to focus on that if we're going to make big headway in age-related diseases. And especially the immune system is important because we have no way in the clinic. There is no test in the clinic today for patients to say, what is the status of your immune system? It's actually remarkable that here we are in 2026 and we don't even have a way to assess that. But we will shortly, because there will be immune system clocks as the first step to determine the pace of aging our immune system. When your immune system is down, when it's gotten senescent, that's when you become vulnerable to these diseases, especially cancer. So these two terms, immunosenescence and inflammaging, a dysregulated immune system is going to promote inflammation throughout the body and in all these organs. And that is what is the basis for these age-related diseases and accelerated aging. And so knowing that, what's really important is that we know that risk factors suppress inflammaging and immunosenescence. Just the things that we have known for years, but even now the data are so compelling that you can get 5 to 7 years of healthy aging starting at age 50, no less even more starting at a younger age. So we know lifestyle factors are very important, and we've learned a lot more about each of them. But we also need something beyond lifestyle factors because we can't count on people to adopt all these, and even when you do, you could be subject to these age-related diseases. And so, for example, we have to deal with the environmental toxins. We don't take care of our land, our air, our water, etc., full of microplastics, nanoplastics, the air pollution, forever chemicals. That's just one part that is going to make this whole progress stalled or even reverse it. Also, we have this issue of the GLP-1 drugs, which I think many of you who've been following this space may realize we've never seen a drug class like this. And these have potent anti-inflammatory. The benefit for the heart, for example, is only 1/3 explained by weight loss. And this transcends the other organs as well, kidney and liver. And so there's excitement about the GLP-1 drugs. In fact, today, in the journal Nature Biotechnology, it was proposed that is this the first drug for longevity? We'll see. That remains to be proven. But Alzheimer's disease is first up for us. We're starting a trial in January, thanks to a philanthropic supporter, to go after prevention of Alzheimer's. Now, pictured here are the amyloid tau proteins, which have been known for a long time as being critically important to progression or development of Alzheimer's. And what we also know, of course, that people think that this is the worst, most dreaded disease. In fact, worse than cancer, stroke, and heart disease combined, and it's on a steep rise. Now, what's interesting is 1 in 4 of us have the ApoE4 allele. How many of you have had an ApoE4 test? Okay, about 4 people. All right, interesting. Well, a lot of reason why people didn't get this is because there's nothing you could do about it. And we didn't understand why it was a significant risk factor for 1 copy, no less 2 copies. Well, now we know, of course, that not only is it prevalent, but guess what? The basis of this, which was described at Duke University in 1993, now we have 100,000 or 10,000 plasma samples and 1,300 cerebrospinal samples. The immune system is dysregulated with the ApoE4 allele, even more so with 2 copies than 1. But moreover, that we understand the immune system and this brain-immune system interaction is the time lag it takes to develop Alzheimer's, which is the same for cardiovascular disease and most cancers. 20 years. It takes 20 years. Don't you think we could get ahead of this with that much of a runway? So here is a plot of the progression of Alzheimer's disease, preclinical, before there's any cognitive impairment, so-called mild cognitive impairment, MCI. That time is interestingly now tracked by a blood plasma protein called p-tau217. How many of you have heard of p-tau217? 4 or 5 people, the same people that the ApoE4 allele. Okay, this is one of the biggest breakthroughs in neuroscience in decades, because this tau protein at its 217 site tracks with Alzheimer's over the course of the 20 years. So if you have a 0 p-tau217, or if you lower it through exercise and diet and lifestyle improvements, you are delaying, at the very least, the onset of Alzheimer's. This is an extraordinary advance in this field. You wouldn't get this test unless you have a high risk. I'm not suggesting people go and get this, only if they have a polygenic risk score, ApoE4 allele, a family history that's of certain Alzheimer's, then you might want to check this. And if it's high, you might want to work on getting it low. This test supersedes all the other tests that have been nominated to track brain inflammation and progression to Alzheimer's. There are many others. In fact, when we get p-tau217, you can get other things like p-tau181 and neurofilament and other neuromarkers of Alzheimer's risk, that is, neuroinflammation markers. Now, why is this important? Well, this is like LDL cholesterol for heart disease, because it's modulatable, right? So here in San Diego, back last April, the American Academy of Neurology had their presentation of this particular study. It's a small study, but randomized. And this is just one of the participants. She lowered her p-tau217 40%, or p-tau 181, 75%, just by lifestyle. And she's representative of all the people in the intervention group. And so we're going to do a much bigger trial to take this to finality of that lifestyle alone makes a difference, and then we'll build on that various candidate drugs. Now, how many of you have had your shingles vaccine? Oh, that's impressive. Okay. Did you know that getting your shingles vaccine lowers your risk of Alzheimer's by 20 to 25%? Did you know that? Yeah. So, yeah. These are 3 huge natural experiments in Wales, in Australia, and the US, and there's 2 more that are soon to be published. Every single one of them is concordant that shingles vaccines, these are natural experiments, better than randomized trials in large populations, just by happenstance of a birthday where that country was giving out the shingles vaccine. And so if this was a drug, this would be considered a blockbuster, that you could reduce Alzheimer's or dementia 25%. And I think you know of dementia, 75% is Alzheimer's. Now, what's interesting is this has nothing to do with the herpes zoster virus. It has to do with raising your immune system's capability, okay? And we can do that even without a herpes zoster vaccine, most likely in the future. So how we're proceeding with Alzheimer's, trying to eradicate this disease once and for all, is to take all these layers of data for each person and using multimodal AI, find the high-risk people, and then come up with ways to, using, for example, brain clock, p-tau 217. These are great surrogates for one's risk over time to try to prevent this from ever happening. There was economists winning the war on cancer. That sounded really good, but at the same time, the New York Magazine said the war on cancer was canceled by the United States government administration. Yes. Well, much of the funding for cancer has, I think you know, been gutted in this country at levels of NIH and other public health agencies. But nonetheless, the progress is unmistakable. So for example, if you have a mammogram, did you know there are 2 companies that are FDA approved that with a normal mammogram will tell you that you still have a high risk in the next 5 years? Most women have no idea that this exists. And this is extraordinary because this is using AI interpreting the mammogram and making a diagnosis of high risk. This is just one way of picking up risks, and there are many others. Hematopoiesis of indeterminate potential. The indeterminate is the worst term because it's clearly increased risk for cancer and cardiovascular disease, and we don't even measure it. And Sloan Kettering, one of our top cancer centers, has shown us that when you have all these layers of data, you can predict cancer many years before a scan detects cancer, which is already too late. That means there's already billions of cells if you can see it on a scan. So we can do this, eventually prevent cancer. And then the last of the 3 big age-related diseases is, of course, cardiovascular. Our group we can do that. And now, just this week, in fact, 2 days ago, Medicare announced that they're paying for these scans that pick up risk, not detecting atherosclerosis, but inflammation in the artery using AI that analyzes the fat around the vessel, which is picking up inflammation. There's 4 companies that have this capability, and what you see pictured here is the fat around the coronary artery that tells the story about how the T cells are activated and the risk for a heart attack or progression of heart disease is there. So we'll get to that too. And not only that, but the retina picture. Someday we'll be taking selfies of our retina. through our smartphone and getting AI analysis. We're not there yet, but that's coming. And the reason for that is because it's rich. It's the richest medical image we know. It can tell whether a person is going to have Parkinson's, Alzheimer's disease 5 to 7 years before they have it. No less diseases of the kidney, the liver, the gallbladder, and this just goes on and on. Of course, establishing risk of heart disease and control of blood pressure, no less blood sugar. Now, a new study just came out last month from Germany, a really impressive study to add to all this. You've heard a lot about large language models. This is the first large health model. And basically, it's predicting diseases in each person 20 years before they occur, okay? And so, again, this is a health model, so it's a disease that's replacing word, all right? And instead of the next word should be, it's what's going to happen in the next 20 years, like pancreatic cancer or heart attack. It's not just telling us what condition or event, it's telling us when, plus or minus months. This is extraordinary, and this is from GPT-2, which is a very primitive, low parameter model. Just think what it will be with much more refined models. We're also going to have people that are using sensors, whether it's a smartwatch or a ring or any others, ways to integrate all that data with the rest of your health data. We've already seen great examples of that. And in addition to that, we, instead of just continuous glucose monitoring, we'll be seeing next year from Northwestern, Shana Kelly and her group, continuous protein monitoring, like inflammation proteins, any protein in the body that can be continuously monitored through a smartphone with a sensor. So this is a lot of advances that are coming. So I just want to leave you with that today, when you get a primary prevention, I put quotes in prevention, checkup, if you get that by a state-of-the-art physician or clinic, you will get your vaccinations. That's good. You'll get a lipid panel and some chemistries, and maybe the doctor will even talk about lifestyle with you, maybe, if they have time. The future is we'll be getting polygenic risk score, genome sequence that can be done for less than $200. It tells us a lot about the risk of these diseases in each person. This model I just talked about, organ clocks, the immune system, not just through an organ clock, epigenetic clocks for the body-wide information, specific biomarkers, the lab, the AI of the labs, the retina and images, and all these other things. So that's why we're going to be able to someday in the future prevent these major age-related diseases. I'm excited about that. Hopefully I've at least piqued your interest in this possibility. It's far-reaching, but it's a lot more attainable than reversing aging. And so someday we'll see that we are going to use AI in a good way, not with the backlashes that we're seeing today. So thanks very much for your attention. Better.
Oops.
Oops. Is it working?
Yeah.
Great.
Thanks so much, Eric. Questions? Please tell us your name and where you're from.
It's Alan Spradling again. Again, still from Baltimore at the Carnegie. I'm all for gathering all the kinds of data you're saying and see what we can learn from it, including predictions. But I think there's a limit because if we, from what we know about many diseases, there are truly like stochastic events that are involved, such as does the 5th gene in a colon cancer sequence to become, truly out of control happen, or doesn't it happen? But it could be due to radiation. And there's also just truly random events from, are you exposed to a certain virus that you didn't know you were going to be? So how do you think, even in principle, could you predict something 20 years in advance which cannot possibly assess these random aspects of disease?
Well, I spoke to Moritz Gerstung, who did that study of that the first large health model. And they were shocked at how accurate it could predict. And that's without other layers of data, like you said. All the viruses, we can get all the viruses you've been exposed to. I had that done and presented those data in the Superagers book, and that will be something that will be available soon for everyone. But the environmental exposures, we can capture that. It wasn't in that model even that I mentioned. But your point about stochastic, yes, part of this health span that's extreme has got to be from good luck, right? Random. But that's not dominant. That's a small part. It may be just similar to the genetic component. So the point being is deep phenotyping, being able to get all this data, including environmental exposures, including viral exposures and other pathogens. These are really critical. That's the only way we're going to be able to get there. And yes, will we ever cover all of it? No. I'll admit that some of this is stochastic, some of it's random, some of luck, but we should be able to make a big difference from where we are today.
Question over here.
Alejandro de Avila from Oaxaca, Mexico. I'm wondering whether you have looked at comparison with data from other countries, because surely the environmental factors are going to be different at different latitudes, but also other epigenetic components. And I think there is much to be learned from there. Of course, the quality of the data is questionable, but in some cases, there might be good reasons to compare.
Yeah, I mean, it's very important to compare from countries. The large health model I mentioned was taking 400,000 people from the UK and 1.9 billion people from Denmark, very different populations. But for example, this week, there was a publication of 86,000 people from 27 countries throughout Europe to establish multilingualism as a very tight, robust link with health span. We didn't know that before. So yes, what you're saying is very important. We're on to something that's, you got to look at multi-ancestry, multinational, absolutely. This isn't, just, one ice pick view.
Another question?
Rowena Matthews, Tucson, Arizona. You've convinced me that you're really much better able to predict who will be a superager with all this information, but you haven't convinced me that you can do anything about it once you do, short of taking a shingles shot.
I'm with you. That's why you have to do studies. That's why we're starting the prevention of Alzheimer's trial. There's never been a prevention of Alzheimer's trial. In December 1st, there's going to be 2 trials with Ozempic in people with mild Alzheimer's reported, large trials, placebo-controlled. If they show that you can change the progression of Alzheimer's, wouldn't it be something that we could actually prevent it? But we do know from all the data that lifestyle makes a big factor for all 3 of these age-related diseases. But we have to prove this idea that having these layers of data, which are not expensive, we're not talking about everybody going out and getting a total body MRI or all sorts of expensive things. We're talking about inexpensive things, integrating the data with the AI tools that we have, but we have to prove it. And that's why we're doing a trial. And once we finish Alzheimer's and layer on other interventions, we'll also be approaching, and others will as well, prevention of cardiovascular disease and of cancer. So this is a work in progress. I'm giving you a preview today of an exciting area. What I'm trying to submit to you is, of all the things that AI can do in medicine, to me, this is the most exciting opportunity. And only years ahead will we know if we actualize it.
Thank you, Eric.
Thank you.
Well, thank you to all of our speakers this afternoon. San Diego has brought us so much, so I certainly found it an exciting afternoon. Before we depart, I have a few announcements. The members' business meeting will begin momentarily in the Woodlands Theater. Cocktails and dinner will be served in the garden courtyard beginning at 5:30 this evening. And I'm not going to tell you where breakfast is going to be because it depends on the rain. And if it doesn't rain, I think it'll still be in the garden courtyard. With that, as you're preparing for tomorrow, please note and remember that the afternoon session tomorrow will be held at Scripps Research, which is just a few minutes from the estancia. The shuttle buses will be leaving from the estancia circle starting at 1:15, with the last shuttle departing at 1:30. If you're planning to drive yourself, there is self-parking available near the Hazen Auditorium, which is where we're going to be. Shuttles will return to the estancia following the concert. And with that, enjoy the evening, and again, let us thank today's speakers who've been outstanding.
Testing what? Every day is a wonderful day here at Estancia. Estancia La Jolla is the best hotel in all of the land. Such beautiful sights here to see, like the little thing they have outside. What is that called? That's not the foyer. What's that called? Flagstone. Whoa. Boosting myself just a little bit. It's my favorite thing to do. Boosting the sound is so awesome. Every day is a dream, and I love to dream. But in order to dream, I have to be asleep. So, okay.